If any truck drivers are watching, they're laughing at me. Finally, time to get back to work. I've set up a crate, a bit of a seat, the floor so I don't fall through. I've got the steering column where it's been, last video. Steering box is in a position. I don't think it's going to be the position. I'm going to get up here and sit in it. Now this is not uncomfortable, frankly. But the steering wheel is just, the column is just too long. I can't get the link here. Even if I cut it down, it's going to be too long. And this is a CV joint. We're in a category of CV joint. But I looked it up online because I didn't really know the name, the proper name, because there's more than one kind of CV joint. This is an RZEPA. Here's a close-up of the RZEPA joint. I don't know why this has this extension like this. And that's as far in as it goes. So it has an extra inch there. I can cut that off the end. Also, I think I can cut out about 2 inches out of this barrel. So I can get 3 inches about off of this. Anyways, that is too long. Steering column's too long. To make a drag link that goes straight from outside the frame to inside the frame and bend a corner. It's not good engineering practice. I really need to have a straight shot. Well, I was looking at the bell crank. Okay, so they've already got one bell crank in there. And I can put a second bell crank in here. Let me see what I'm talking about. Well, there's the bell crank. And on the back there, you see it's to the tie rod. This end of the bell crank, that hole had a ball joint, and that is 90 degrees to where the steering box used to be located outside this frame. Well, steering box is up there. This is what I got off the fire truck. This used to be transferred the clutch movement from outside here to inside here. It's got pretty good bearings, brass bushings, front and rear. It has grease points right there and right there, and this rod which needs cleaning up, but it's got no wear on it at all. It's got some rust. I think this shot shows it all. Got the bottom of the pitman arm, bell cranks over there. This is where the steering box used to be located. It's pointing in that direction. The drag link was. But now I'll have this mounted outboard, about 7.5 inches or so. And the drag link from the steering box can go straight in. It's a 7-inch arm. It's got to be a 7-inch arm paralleling the frame here. And then I'll have a second arm that comes out in this, this direction. It's slightly off. But that'll be a straight shot to the bell crank over there. I realized by doing this, it's going to add some slop, perhaps, and not good in a steering system. But I think it's going to be superior to having an elbow in the drag link. Lined up there, lined up there. Let's make a mark. Well, at this point, I'm going to have to work on the frame alone. I don't need the cab. The cab's just in the way, so cab comes off. Steering box is no longer going to be at this angle. It's going to be approximately in this location, in line with the frame and all that. But it's not going to be at this angle or that angle or any of that. It's going to be something else. So I'm just going to measure here. The cab was about at this position. So I'll just measure that. Can't go any further forward than that. And I'll mark it as, say, 15.5 inches to here. Here's the line. Here's my bell crank. I'm just going to confirm if I'm turning left, the bell crank goes right. If I'm turning right, the bell crank goes left. Okay, so put them straight forward again. It's a funny thing, when this thing's off the ground, the wheels toe out. Anyways, so that's a right angle. I need to push on there. Okay, so when the steering box pushes, I want that to push, because that's how the steering box was directly pushed on that. Okay, so if I'm mounting this here somewhere, it's got to be at a right angle. If I had it, I have to have it out here. And to be at a right angle, I've got to mount it back this way. I think there's going to be a problem interfering with the tire. I think it's about time I mount the front wheels. I have some front wheels, but I don't have tires yet. The tires are pretty expensive. I don't want to buy them until I know I need them. I've got some cheap rims. They're 22.5 rims by 8.5 wide. And I only paid $50 a piece for them, plus shipping. They are heavy. They weigh about as much as the tire and rim combination that I'm pulling off. The rims alone do. Anyways, those are, if I fit those to a 255/70 22.5 tire, that's just a little over 36-inch diameter, outside diameter. Now the rim isn't going to work because it's all offset. I mean, it's a dually wheel, and that puts it far too much inboard here. So it's just for mock-up at this point. But still, I need to put that on just to see where the tire is about going to, the amount of clearance that I need. And I'll bring in some rims from the old fire truck, the rear axle. I'll take off one pair of those duals and stick them on here, see what it looks like. I've had all the other 5 wheels off, and torquing has been pretty indifferent. Some have been just on there like wow, and other ones are almost loose. Anyways, let's see how we go with this one. Owing to how hard those other ones came off on that motorhome that were pretty small lug nuts, these are much larger. I'm hoping this 3/4 drive stuff is going to be up to the task. Left-hand threads. It either broke free, the wrench seems to be in one piece. 1 down, 9 to go. Learn something every day. So I've been beating on this thing and hammering on this thing. I even used heat. This wheel wasn't budging. And I actually even bashed on these studs. I noticed that they were loose. And then I remembered that these have this little square drive thing on it. Well, if any truck drivers are watching, they're laughing at me because this screws right off. These studs are actually lug nuts. Who knew? Here's where I go into the discussion about wheel choice. Behind me, it's a 20-inch rim. It's got a 20 by 10 tire that was from a 1968 fire truck. And it's 40 inches high. It's too big. It would fit the wheel well, but it doesn't fit the chassis. I think they call them Bud rims. Maybe it's just a manufacturer, but it's got a locking ring. And I think they're still in use today, but they're not very common, and they're kind of hazardous to use. Plus, it's a tube type. This is a tube type rim. I want to use a tubeless. Anyways, to use a tubeless, and for some other reasons, it's got to be a 22.5-inch rim. So how'd I get there? I need a fairly narrow tire. I can't really have a fat one because there's just not enough room here without changing some stuff. Even if I did choose to have a really fat rim, a fat tire, it's only in a mud grip, a really aggressive, at least that's the only kind I could find. Off-roaders use a relatively small rim, could be an 18 or a 17 or smaller. But then you have a really high sidewall and a really fat tire. And I didn't like the appearance of the tread. I needed a narrow, street sort of tread. And in order to get the height I need, 36 inches, I had to use a pretty big diameter rim. But even at 22.5, it's hard to get a big diameter tire. I have managed to find a tire that'll work. It's still a truck tire. It's 16 ply. I haven't bought one yet because they're kind of expensive. I'm trying to find a used one that I can just use for mock-up. Even those are about $100 a piece because people don't sell junk tires. They sell something that still has some life. The trouble with the rim like that, though, is it has a massive positive offset. Now, positive offset means it bolts here, but the actual rim is back here, and that causes an interference problem with the frame. If this axle stuck out further, it wouldn't be a problem, but this is what I have. I'm not going to change this. It's way too hard to change. That means still, even with that rim, and that's why I went with the cheap rim, I'm just using it for mock-up, and at some point I'm going to have to figure out where to get a rim or how to modify these rims to change the offset so it's more negative, or less positive. It needs to come outward 4 to 5 or maybe even 6 inches. Instead of the bolt pattern being on the outside of the tire, it's going to be somewhere in the middle of the rim. There may be some problems with bearings in here. This has always had a rim with a massive negative positive offset. This is what they call a 6.5 by 8 bolt pattern, GMC. It's not only GMC, other manufacturers use that bolt pattern. It's pretty common. It means it's 6.5 inches across at the widest diameter, and there's 8 bolts. In order to get to a big truck rim like that is, I can't remember what that is at the moment, but it's a big, much larger 10-bolt pattern. I found adapters. These are aluminum, and they're 1.5 wide. These are made for dually tires. That's why the studs are so long. I won't be using all of that because I'm going to have just a single rim on here. So I'm just going to bolt these on, only half the nuts. I'm not going to use all the lugs. And same with the big rim. And I'm just going to set that on here. And that tire is still too big. It's 40 inches diameter. Basically, if I can make that 40-inch fit, I can make anything smaller fit. Let's bolt this on and see what we've got, because I haven't actually done this yet. Let me clean these up first. When I bought these from the manufacturer of the spacers, they came supplied with these nuts, these lug bolts. And I think I'd noticed early on that they were wrong. They were the wrong thread, metric thread or something. These are not metric. And I bought these I think I bought them online from Amazon. Same style, just a different thread. just for comparison, there's the original, this is on the back axle, the original 30-inch tire. And here's the 40-inch. Those are side by side. Whew, big difference. Oh, this is one of those things where they talk about hub-centered wheel or lug-centered wheel. If this were a lug-centered wheel, the lug nuts that I had when I pulled this rim off, the lug nuts all had a taper, and the taper fit into this big hole and centered the wheel. It actually also had hub centering on the truck axle. Well, this is a hub-centered adapter, and that's fine because these nuts are going to pull it on, but the hub's going to hold it centered. Now, again, the width of the tire is a problem here where it strikes the sway bar. And again, the offset, the wheel's got to come out. And that will help also with the back. Just the diameter of the tire being 2 inches too large would get me a little bit of room here, but it's still too far in. So that's got to come out as well, and that's hopefully will give me some turning radius before it starts scrubbing on the inside of there. From the factory, the rear track on the motorhome was always wider than the steering axle. And you can see here it's even more so with this rim because the offset is even so much greater than it was on the stock rim. The wheels are way inboard compared to the back tires. So I can come out quite a ways, and this still will look all right. Not that that's a huge concern, but looks are a concern. Well, the tires are flat. They've got no air pressure in them. Even then, I think maybe I've lost 1 inch is all. The back suspension is deflated. It's sitting on jack stands back there, but there's no air pressure in those bags, and those will probably be a little bit higher than that now anyway. So the front's going to come down, especially when I put the cab on. That's going to have some weight. It'll compress the suspension in front a little bit. One more step. I can get an impression of what it's going to look like in reality. To make it look nice, if I repositioned the steering box to be here, the arm would push directly in line alongside the outside of the frame here. And for that to be a pushing motion, for example, this would have to be out here, but back here ways, because that arm is about 7 inches long. It pushes in this direction. A second arm down lower would come out this direction, and that would push on that arm there, the second bell crank. Well, you can see that it would hit the tire. Let's call it a hinge. Now that I can put this hinge forward, I know it's not going to interfere with the tire. I just have to pick a spot fore and aft so that this lever, 7 inches long, this is off the steering box, 7 inches center to center. I'll go about here. Camera probably can't pick this up too well, but from 90 degrees from this hole is about, right now, 90 degrees to this hole. And at that point, I need a second lever. Imagine this is now part of the second lever, and that'll have to be pointed somewhat to where the steering box is going to be up front there. This is just another piece of the truck frame. It's the same as back there where it fit around. I can place that on there, slide it back and forth wherever I need it. I'll just need a bracket to hold the hinge. Well, this came off the truck frame too. That's the hinge. And that's the original bolt pattern, the original bolting plate that braced it on the inside. I just need to cut this here and here, weld it onto this plate, and bolt this in there where it needs to fit. And with that in place, I can go ahead and I want this grease joint facing out. I've made my bracket and I've done some bracing on it, so that I was thinking I'd have some piece here supporting this from wanting to pivot in and out, whatever. But it was proving to be too difficult for me to figure out how to do. I opted to put in some gussets here and here, and it still bolts in there easily. and it allows me access to the grease points here. I think that'll do. So there's the thing, and that's about where it has to go. When I get my lever on here, that is about where that's going to go, and it's out of the way of the tire, and it can be moved forward a little bit, I think, because again, I want that to be a right angle to here. This is the transmission. Here's the clutch operator. That's the pilot bearing. And I'm just looking, this is all 1 inch. Now that other rod that I have in there is good, it's fine, it's just too long. Well, this is also 1 inch and it's shorter. I'm going to see if I can take this bolt out here and just pull out this thing in one piece. Oh, what's that? Oh, that's a keyway, or a washer with a bolt through it that held that key in place. Interesting. There we go. Let's see how that fits in this application. There's the rod that came out of the bell housing for the transmission. It's the right length, but unfortunately it's got quite a bit of wear in this area here, which kind of interferes with how that's made. So I'll use the original long rod. And that's all well, because these are all going to fit fine. To keep this rod from floating up and down, I'll probably have to have some kind of thrust bearing or, I don't know, just a washer. I might just come up with the brass washer down here. I'll put this little lever here on it, if I can get that key in there. Pretty press fit. And that'll be my thing that keeps it in place. And, you know, later on I can cut this off. I don't want to cut it off just yet because I still might need it for in somewhere else. I still have this rod which came off the transmission, or this lever. And it's a tight fit, so I'm not going to try to put it on there just now. Too bad it's too short. This lever needs to be this long. So if this were forged, I could probably weld to it. Just weld some new arms onto it. But if it's cast, don't know. I don't know how to tell. This is the original drag link that came off the motorhome. This end is damaged because I had trouble getting it off. And in any case, I'm going to have to use a heam joint on this end because I don't know how to make myself. I don't know. I have to make levers. And am I going to make a levers with a tapered hole in it? I don't think so. That's about the right length, I guess. That's going to be at a right angle, so it'll be out like this. About there. And that's got clearance. And then the other lever again, going to be here, toward the steering box. Well, I've done some research. This is the pitman arm off the motorhome. And trying to find out, differences between forged and cast. Like I say, forged, I think I could weld to. Cast, I wouldn't want to try. This pitman arm, I don't know if you can see that, but that has a wide and smooth trim. That's a seam between forge halves. And that's pretty typical. The finish of it's pretty smooth. It does have a number on it, and depending on what you listen to, they're saying forge pieces don't have raised lettering. Well, this one does, and it's a forging, so it must be they're able to do it. This is off the fire truck. The finish is different. It's got like a sand cast finish. Yeah, I think that's not a forging. Anyways, I'm not going to try to weld to that. I'll make something out of something that has a 1 inch ID and then weld bits to it. As far as finding ball joints and heam joints, the heam joints are, I ordered those online. And the ball joints are just standard GM stuff that I got in town at the store, at the dealership. Pretty cheap. They're the right things. This is a what they call a link. And it has these bits here that are clamps. That's split down the middle. And this has right and left hand threads in it, so that when you turn it, the ball joints that it's made to use can go apart and together at the same time without disconnecting anything. And these are clamps. When you get done adjusting, you use that clamp, you tighten it down on the threads, and that keeps it in position. My plan here is I will use 2 ball joints that would fit on either the pitman arm or on this bell crank. These are both left-hand thread. On the right-hand parts, the right-hand threaded portions will just be a standard 11/16 18 or 11/16 fine thread hardened bolt. They'll just go in between there, and that will be how those join together. So that's part of the, becomes part of my drag link. I'll make them identical, well, more or less identical. This one will be shorter than the one that goes here. So I'll have a heam joint on this end, be joined by a bolt on these two, and I'll probably have a long bolt here. And it can't be all thread, because they don't make, as far as I know, they don't make an 11/16 18 all thread. So I'll have to have something made. Steering box goes here. I'll have this pitman arm will be attached to this one, wherever that needs to be. I'll have the other end here, and that goes to the other end of this lever. They have to point at it, so I have to figure out where that location is. And then the other one will be under here. 2 links, and then the heam joint attaches on this lever. And that's the plan. So I reckon I can just use the standard 11/16 18 bolt for the short one. Should be enough thread. Just bolt them together, clamp it together. The other one though, is going to have to be a longer bit of bolt. And because I'm a little bit worried about it bending, because maybe it might be a mild steel bolt. I don't know what kind of bolt all thread I can get. Or it may not be all thread. I might have a machine shop just take a bit of hardened bar and thread it on the ends a couple of inches on either end to a length that I tell them. And but still, is that rigid enough? I don't know. I can stick a tube over it. That's just a little bit, that the bolt fits into, and that'll give it the rigidity that it needs. And I can just crank that tight. All my adjustment will be taking off the heam joint and then screwing that around. Will that be long term? I don't know, but it's going to just get this thing on the road as a proof of concept. This video has gotten a bit longer, again, than I wanted it to be. I've tried to show a lot of things. Tried to describe a lot of really, for me even, difficult to understand geometry. So anyways, I'm going to put this video out. Consider subscribing. Thank you for watching. Give me a thumbs up, and I'll see you next time.